The displacement function now will be a function of both x and y, a linear function, and we can show this linear variation graphically on this figure. Say this is x-axis and this is y-axis, and the quantity of interest, in this case u and v. It stands for both u as well as v. Now the element, which is an area element in this case, and the shape is triangular. It is in the xy plane because we're talking about 2D element here. This is I node, this is j node, this is the k node. We have 3 nodes here, and the coordinates are xi, yi, xk, yk, xj, yj. And as far as the quantity of interest phi is concerned, that the value at the I node is phi I, the value at the j node is phi j, and the value at the k node is phi k. Now the linear variation means we join them in a straight, each of them with a straight line. So this is the value of phi anywhere in the element. Now the next step would be calculation of alpha 1, alpha 2 and alpha 3. So we write this for the 3 nodal points: alpha 1 plus alpha 2 xi plus alpha 3 yi. Similarly, phi j will be alpha 1 plus alpha 2 xj plus alpha 3 yj. Phi k, alpha 1 plus alpha 2 xk, alpha 3 yk. And similar to the procedure done for the 1D element, we write it in matrix form like this. It's easy to remember and easy to manipulate in this way. And we have xi, yi, xj, yj, xk, yk, and here we have alpha 1, alpha 2 and alpha 3. Now symbolically we can write this as a y vector, x matrix and alpha vector. Again, we are interested in the calculation of alphas, so we rearrange it in this way. Now here x matrix is the matrix enclosed in blue. This is the x matrix. This is the x matrix. Now this is a 3 by 3 matrix, so inverting it is slightly more complicated than was the case for a 2 by 2 matrix, but still there is nothing very difficult about it. So let's start the process. Now let's write x down here. X is basically 1, 1, 1, xi, yi, xj, yj, xk, yk. This is the matrix. Now its inverse will be a joint of x over the determinant of x. This is how we calculate the inverse. Now let's start with the determinant first. This is simply 1, 1, 1, xi, yi, xj, yj, xk, yk, and this happens to be equal to twice the area of this element, this triangle. This can be verified from analytical geometry text. Now let's come to the adjoint of x. This requires 2 to 3 steps. So we first take up minor x, and that is again a simple procedure. Here we have xj yk minus xk yj yk minus yj xk minus xj. Essentially what we do here is the element we are talking about, we ignore that row and that column and they take the determinant of the rest. Now xi yk minus xk yi yk minus yi xk minus xi. Similarly, now we take this xi yj minus xj yi yj minus yi xj minus xi. You should verify this for yourself. Now from at minor xij we calculate the cofactor. We are getting another step closer to calculation of adjoint. Now this is simply minus 1 power I plus j multiplied by the minor xij. That is, we have to add the column and the row number, and if it's an even number we leave it as it is. If it's an odd number we change the sign, and that means this one remains as it is because 1 plus 1 power is 2. Here we change the sign. This one again remains the same, and here we change the sign. This one remains the same, change sign here. This remains same, sign is changed here, and this one remains the same. So we have taken now the cofactor of x. Now adjoint as x is simply the transpose of cofactor. That's a simple matter. We have this, just replace rows with columns. So xj yk minus xk yj, this doesn't change place, but this one does. Similarly, xj minus xj yi. Now we have yj minus yk minus yi minus yj, and then we have xk minus xj xi minus xk and xj minus xi. So we have the adjoint of x. All that remains now is putting these values in our original expression, which was this. Recall that the determinant is twice the area of the triangle. The rest is the same. We need to put this here. That will give us the inverse of the x matrix. But instead of writing this complicated expression, let's call this ai, let's call this one aj, this one ak, bi, bj, bk, ci, Cj, Ck, which means that we can just simply write Ai, Aj, Ak, Bi, Bj, Ek, Ci, Cj, and Ck. This is the inverse of x. Now let's put this back in our original equation. That was, how it will be: alpha 1, alpha 2, alpha 3 is equal to 1 over 2a, ai, aj, ak, bi, bj, bk, ci, cj, ck into phi I, phi j, phi k. Now recall our original interpolation function. That was alpha 1 plus alpha 2x plus alpha 3y. Let's write it in matrix form as 1 x y alpha 1 alpha 2 alpha 3. Now we have value of this we have here, so replace this in this expression. This is 1, this is x, this is y, and then you have 1 over 2a, ai, aj, ak, bi, bj, bk, ci, cj, ck, and then we have phi I, phi j, and phi k. Now rearranging and simplifying, 1 over 2a goes to the left, and then multiply these two matrices and we get ai plus bix plus ciy. Here we get aj plus bjx plus cjy, and then ak plus bkx plus cky, and at the end we have phi I, phi j, and phi k. Or we can say, like we did in the case of 1D simplex element, ni, nj, nk, phi I, phi j, phi k, and this gives us the value of phi. So this is an interpolation function where ni is equal to ai plus bix plus ciy over 2a, nj is equal to aj plus bjx plus cjy over 2a, and nk is equal to ak plus bkx plus cky over 2a. Now this is a very simple expression and shape is the same for all. That is why we can even simplify it further by writing it like, all of these can be written as n for beta is equal to a beta plus b beta x plus c beta y over 2a, where beta takes the form I, j, and k. Now obviously this is a very simple expression, but the devil is in the details. The expressions are rather complicated. So is there an easier way to express them about the coefficients? About ai, recall that it is xj, yk. Please confirm this, xk, yj. Now if we can write it in matrix form, this expression takes the shape x, y, j here, k here. This is the same expression. On the left you have an x column, on the right you have y column. and subscript for a is I, and you go from I to j to k in a clockwise manner. So if there's I here, then the next should be j, and then the next should be k. And similar expressions can be written for other expressions. For example, this was the value of aj, and we get this by similar determinant x column, y column. Now here it is j, so we should write k as subscription, then I, because we have to go like this always. And you can verify that you get the same expression, but this one is much easier to memorize. Please verify that AK by the same scheme takes the form x, x, y, k here, so we have I, j, j. What about B's? Bi, if you recall, was yj minus yk. Now again, if we try to write it using a similar scheme, to the left there should be column for x, on the right column for y. Y will be here, but there is no x in this expression, so just write 1 here. And because this is I, so you should write j and k in sequence here. You have j here and k here, but you don't get the same result as this one unless you put a minus sign here. Now we take bj. Now bj is yk minus yi. Similar scheme, you have minus sign 1 1, here you have y's, and because it's j here, so k, and then you have I. And then you can similarly verify that bk by the same scheme should be 1 1 I and j. Now we have taken care of A's and B's. Now we come to C's. Ci is equal to, from the original expression, xk minus xj. Again, write it in matrix form and maintaining the position of x and y, x in the left column but y in the right column. Now there is no y in this expression, so on the right you have 1. There are x's, you write them here. This is I, so by the same scheme, this right should be j and then k, but you'll see that you get xj minus xk, not xk minus xj as we would like to have. So you add a minus sign here. Of course, if we don't add a minus sign here, then the columns will have to be interchanged, but we want this x to remain on the left hand side, so that there is uniformity. Now by the same scheme, you can confirm that cj will then become 1 1 k and I, and ck by the same scheme should become I and j. So once you have calculated these 9, then you go back to these expressions, and you can calculate shape functions, and then putting these shape functions into this give you the interpolation function as a function of x and y, and you can put values of x and y and you get the displacement anywhere. Now again, I'll reiterate that phi here stands for both u and v, because this is a 2D element and displacement is a vector with 2 components, u and v. Now let's examine the properties of shape functions. If this is I, j and k node, these are the nodes, then what are the properties of shape functions? number 1, 3 in number. These are 3 in number, ni, nj, and k, equal to the number of nodes. Well, that makes sense. Similarly, it can be shown that ni is equal to 1 at node I and 0 at nodes j and k. And similarly, similar is the case for nj and nk. That is, nj will be 1 at node j and 0 at node I and k, and so on. And it makes all the sense in the world, because at node I, the value of phi should be phi I. Now phi I multiplies with ni, so ni has to be 1, and nj and nk have to be 0 to give phi is equal to phi I. So this makes sense. And third property is similar to the 1D case. Everywhere ni plus nj plus nk add up to 1. Now you can write the expressions for ni, nj, and nk here, and after simplification you will see that you get a value of 1. You can verify this for yourself. Now, if we know that ni is equal to 1 here, and ni is equal to 0 here, and ni is equal to 0 here, we can draw a line joining j and k, or through j and k, and say that on this line ni is equal to 0. Then what we can do is we can draw a line parallel to this line, but this time it passes through I, and say that ni is equal to 1 here. Then it stands to reason that in between the two lines ni must be 0.5, and in between these two ni should be 0.75, and here ni should be 0.2. We can repeat the same process, for example, for nj. We know that nj is equal to 1 here, nj is equal to 0 on this node, nj is equal to 0 on this node. So what we can do is draw a line through node I and node k, and say that on this line nj is equal to 0. And then we can pass a line parallel to this line, but this time passing through the j node, and say that nj is equal to 1 here. And in between the two, nj should be 0.5. And similarly for lines that here we can say that nj should be 0.75, and on this one nj should be 0.25. And similarly we can pass similar lines for nk. So for every point inside this element there will be a value of ni and nj and nk, and if you add them all together you will get 1. Let's take up a problem to reinforce our learning. A 2D simplex element is given here, and which means that there will be nodes here, here, and here. Now the first step, number the nodes. You can take any of the 3 nodes as node I. Let's say this is node I. You could have taken any other as node I too, but once you decide you have taken this as node I, then make sure that you always go in an anti-clockwise manner to number nodes j and k. So if this is I, then this must be j and this must be k. The reason being, this is just one element given, but in any given problem there will be many elements like this. This won't be just one element. Now we must be consistent in numbering of our nodes. While for any given element we can take I node wherever we like, but once we select the I node, then we must number the j and k nodes by going counterclockwise for all the elements. If we are not consistent in this practice, then there'll be problems. So if this is I, then this is, the coordinates are 50 and 30. For j, the coordinates are 70 and 50. For k, the coordinates are 55 and 60. Now what we need to do is, for shape functions we need to have these quantities: a beta plus b beta x plus c beta y over 2a. So we need 3 a's, 3 b's and 3 c's, as well as 2a. Now 2a is equal to the determinant. We have gone through this. So that is xi, yi, xj, yj, xk, yk. In this case it will become, just put in the coordinates 50, 30, 70, 50, 55 and 60. Now you can calculate the value of 2a and you can verify that this turns out to be 500 square millimeters. Now you have taken care of 2a. Now let's calculate the a's and the b's and the c's. Now let's recall our expressions for a, b and c. X column, then y column. This is I, so it's j, j, k, k. Now just put in the values 70, 50, 55, 60. Now this turns out to be 1450. AJ, similar scheme, X, X, Y, Y, you have K here now. Then we have I. Put in the values, we have 55, 60, and here you have 50 and 30. Now this turns out to be minus 1350. You should verify these numbers. Now AK, similarly X, X, Y, Y, I, and J and J. Now you have 50, 30 here, this one, and then you have 70 and 50. It's kind of a cycle going on here. And this turns out to be 400. Now there's a check whether you have calculated the A's correctly, and that is add them all together and they should be equal to 2A. Let's add them together. 1450, 1850, 1850 minus 1350. You have AI plus AJ plus AK is equal to 500, which is indeed equal to 2A. So we are going the right direction. Why AI plus AJ plus AK should become 2A is because recall that NI plus NJ plus NK, we discussed this. This was property number 3 is equal to 1 everywhere. Now if we put in the values for Ni, Nj and Nk, the general expression for Ni, Nj and Nk, we get something like AI plus Bix plus Ciy plus Aj plus Bjx plus Cjy plus AK plus Bkx plus Cky. These are the 3 shape functions. Now this should be equal to 1. Now we can rewrite it like this. AI plus AJ plus AK plus BI plus BJ plus BK X plus CI plus CJ plus CKY. Now, because there are variables X and Y here, they have to become 0 for this left hand side to become a constant. 1 is a constant. So this means that BI plus BJ plus BK must add up to 0. In that case, X will disappear. Recall that in the one-dimensional case, when you added Ni and Nj, X disappeared. Here, same thing should happen. And this term with Y to become 0, the Ci plus Cj plus Ck must become 0. So that Y disappears also. Now what remains is AI plus AJ plus AK over 2A. Now on the right hand side we have 1. The only way this left hand side will become 1 is if AI plus AJ plus AK becomes 2A. So AI plus AJ plus AK in all problems, for all situations, for all elements should be equal to 2A, and BI plus BJ plus BK should always add up to 0, and CI plus CJ plus CK should all add up to 0. We have checked this already. Now let's calculate B's and C's and check whether that is the case. Now for BI, recall that there was a minus sign here. In the X column there was 1, YJ, YK. This is minus 1, 1, 1. Please confirm that this is 50 and this is 60, and you have minus 10 here. BJ, again the same scheme, 1, 1. This time there should be YK and YI, 1, 1, and you have 60 and 30. So you get 30 here, and BK minus 1, 1. You have I, J, 1, 1. You have 30 and 50 here. So you get minus 20. Again, you check BI plus BJ plus BK is equal to 0. So we are going in the right direction. Similarly, C's. For C's, there was a minus here. You had 1 on the Y column, X in the X column, and here should be YJ and YK. So you have 70, 55, 1, 1. You get minus 15. CJ equal to minus XK XI 1, 1, which means 55, 51, 1. This is minus 5. Finally, CK XI XJ 1, 1, 50, 70, and the negative sign outside. So you have 20. Again, CI plus CJ plus CK is equal to 0, and this means that our values are correct. Now recall that 2A was 500, so all we need now to write the shape function Ni, which is a function of X and Y in this case, 1 over 2A, 1 over 500. Now AI was 1450, AJ was minus 1350, and AK was 400. We just put in the values here. 1450 minus 10x, this is BI, minus 15y, this minus 15 is CI, and the rest is the format. So similarly, NJ, again function of X and Y, determinant is the same. Now you have minus 1350 plus 30x, this 30 is BJ, and this 30 is bj, and minus 5 is cj, and nk 1 over 500, and 400, this a is 400 minus 20x, 20 is bk, and plus 20y. This is ck. This 20 ck is 20. Now you can also verify that these expressions, put in the values in for example, if you take ni, so if you put the coordinates of node I, the x and y coordinates, you should get 1. But if you put the same coordinates of node I in the expressions for nj and nk, you should get 0. And the same goes for the other two shape functions. Now the second part wants us to calculate the shape function values at coordinates 60 and 50. And 60 and 50 means talking about this point. What is the value of ni, nj, and nk at this point? It's very simple. We have the expressions for ni, nj, and nk. All we need to do is replace x by 60 and y by 50. So ni becomes 1 over 500, 14, 50 minus 10 into 60 minus 15 into 50, and this turns out to be 0.2. Now nj, again putting the same coordinates, minus 1350, we should verify these values, minus 5 into 50, and this turns out to be 0.4. Now, before even calculating nk, we know what nk should be, because we know that ni plus nj plus nk, they are always equal to 1, so nk must be 0.4. But still, if we put in the values 400 minus 20, 60 plus 20, 50 is equal to, indeed, turns out to be 0.4.